In this episode of Surds Part 2, we will be carrying out addition, subtraction and multiplication of surds, determining conjugates of surds, rationalization of denominators of surds, and finding the positive square roots of surds. You will need to pause a little to take these exercises down, because we will cover every aspect of these exercises. When carrying out addition, subtraction, or multiplication in surds, it is advisable that the component surds be simplified first before you carry out the operation. A. Root 72 plus root 8. Now recall that root 72 can be further simplified into root 36 times 2, which is equal to root 36 times root 2, and this will give us 6 root 2. Then root 8 is the same thing as root 4 times 2, which is the same thing as root 4 times root 2. This is equal to 2 root 2. I must add here that you cannot carry out addition or subtraction if the component surds are of not the same root. That is the reason we are simplifying. So root 72 is 6 root 2 and root 8 is 2 root 2. So we have root 72 plus root 8 will become 6 root 2 plus 2 root 2. This will give us 8 root 2. Now let us look at B. B says root 27 minus root 12. Then we have to simplify to the same root for each component. Root 27 is the same as root 9 times 3. This will give us root 9 times root 3. This is 3 root 3. Root 12 on the other hand is the same as root 4 times 3. This will give us root 4 times root 3. This is something as 2 root 3. So root 27 minus root 12 will give us 3 root 3 minus 2 root 3. This will give us root 3, and that is our answer. So for C, we are asked to look for, to expand 2 root 2 minus 1. All squared. This is the same thing as 2 root 2 minus 1 into 2 root 2 minus 1. Now in carrying out multiplication, we must multiply individual terms in both brackets. Now this is what I mean by multiplying individual terms in both brackets. Two root 2, we multiply 2 root 2. 2 root 2, we multiply 1. Minus 1, we multiply 2 root 2. and minus 1 will multiply 1, in that order. So we have 2 root 2 times 2 root 2, that will give us 4 times 2, 8. 2 root 2 times minus 1 will give you minus 2 root 2. Minus 1 times 2 root 2 will give us minus 2 root 2. Minus 1 times 1 will give us plus 1. This will give us 8 plus 1 minus 2 root 2 minus 2 root 2, and that will give us 9 minus 4 root 2. So 2 root 2 minus 1 all squared will give us 9 minus 4 root 2. The conjugate of a surd is another surd that when you multiply it with that surd, you will have a result that is not a surd. We use conjugate to rationalize surds. It is important for us to know how to get the conjugate. A says multiply 2 root 3 minus 1 with its conjugate. Now the conjugate of 2 root 3 minus 1 must be 2 root 3 plus 1. All I need to do is to change the sign of the minus 1 here and make it plus 1. That is the conjugate. So we multiply like we did in the first place. We multiply this surd with this, then we multiply this with this, we multiply this with this, then we multiply this with this. So this will give us 2 root 3 times 2 root 3 will give us 4 times 3, that is 12. 2 root 3 plus 1 times 1 will give us plus 2 root 3. Minus 1 times 2 root 3 will give us minus 2 root 3. Minus 1 times 1 will give us minus 1. You can see that when we add 2 root 3 with minus 2 root 3, the surds will be removed. What we have left is 12 minus 1. So this will give us 12 minus 1, and this will give us 11. B, 1 minus root 5 multiplied by its conjugate will give us, the root conjugate is 1 plus root 5. So 1 times 1 is 1. 1 times root 5 will give us plus root 5. Minus root 5 times 1 will give us minus root 5. And minus root 5 times minus plus root 5 will give us minus 5. This will give us 1 minus 5, which is equal to minus 4. Rationalization of surds means removing all surds in denominators of any fractions. Here we have 3 cases that we are going to look, and we are going to rationalize them. We have different forms of doing that, but the bottom line, the idea is that it must be a fraction and the denominator must not contain any surd. A, 4 over root 3. When we rationalize, We are only changing the arrangement, but the values remain the same. In rationalization, you just multiply the surd with 1, but you multiply it with something that is of value 1. In this particular case, if we multiply 4 over root 3 with 1, we'll get 4 over root 3. If we multiply 4 over root 3 with a over a, which is also 1, we'll get 4a over a root 3, which is the same thing as 4 over root 3. So 4 over root 3 times root 3 over root 3. Root 3 over root 3 is 1. So this is the same thing as 4 root 3 over root 9, which is equal to 4 root 3 over 3. This is our answer. B, we have 4 over root 5 plus root 3. In this particular case, we are going to multiply both the numerator and the denominator with the conjugate of the denominator. This is our rationalization. So this will give us 4 over root 5 plus root 3 times root 5 minus root 3 all over root 5 minus root 3. We have not changed the value, we just changed the arrangement. This will give us 4 into root 5 minus root 3 all over root 5 times root 5 will give us 5. Root 5 times minus root 3 will give us minus root 15. Root 3 times root 5 will give us plus root 15. Root 3 times minus root 3 will give us minus 3. So this will give us 4 root 5 minus root 3 all over 5 minus 3. This is the same thing as 4 root 5 minus root 3 over 2. So 2 in 4 will give us 2. 2 in 2 will give us 1. That's 2 root 3 over root 2 into root 5 minus root 3. We cannot further simplify this. This is our answer. Okay, the C part says express 3 root 5 minus root 3 all over 2 root 5 plus 3 root 3, and they form a root 15 plus b. So what we'll do is C, we'll say 3 root 5 minus root 3 all over 2 root 5 plus 3 root 3, and we must express it in the form a root 15 plus b. So what we'll do is we'll simplify this to the point that it will get to this. So we have to rationalize 3 root 5 minus root 3 all over 2 root 5 plus 3 root 3 times the conjugate 2 root 5 minus 3 root 3 all over 2 root 5 minus 3 root 3. This is equal to 3 root 5 times 2 root 5 will give us 6 root 25. 3 root 5 times minus 3 root 3 will give us minus 9 root 15 minus root 3 times 2 root 5 will give us minus 2 root 15 minus root 3 times minus 3 root 3 will give us plus 3 root 9 all over 2 root 5 times 2 root 5, that is 4 root 25 2 root 5 times 3 root 3 will give us minus 6 root 15. 3 root 3 times 2 root 5 will give us plus 6 root 15. And 3 root 3 times minus 3 root 3 will give us minus 9 root 9. Okay, we simplify this further. 6 root 25 is 30 minus 11 root 15 plus 9, that's 3 root 9 will give us 9 all over 20 minus 6 root 15 plus 6 root 15 will cancel out, minus 27. So this, rearrange this, you're going to have minus 11 root 15 plus 30 plus 9 all over minus 7. This will give us minus 11 root 15 plus 39 all over minus 7. Let us break this into partial fractions. We are going to have minus 11 root 15 over minus 7 minus 39 over 7. So this will give us 11 over 7 root 15 minus 39 over 7, and we have put this in the form a root 15 plus b. So what this means is that our a is equal to 11 over 7 and our b is equal to minus 39 over 7. We can look for the square root of surds also, but we have a way of looking for them. Now the square root of a number is that number when you times it by itself, it gives you a perfect square. For instance, we are looking for the square root for a. Now we're looking for the square root of 19 plus 6 root 2. So this is surd, but we can get the square root. And let us say, let the square root b root a plus root b. So what this means is that when we multiply root a plus root b by itself, that is when we square it, we get 19 plus 6 root 2. So we have to expand root a plus root b into root a plus root b. This must give us 19 plus 6 root 2. So root a times root a will give us a. Root a times b, root b will give us plus root ab. Root b times root a will give us plus root ab. Root b times root b will give us b. A plus b plus root ab plus root ab. So this will give us a plus b plus 2 root ab. So let us compare this with 19 plus 6 root 2. We have a plus b plus 2 root ab is equal to 19 plus 6 root 2. What this means is that a plus b is equal to 19. Therefore, our a is equal to 19 minus b. And 2 root ab is equal to 6 root 2. For us to have something similar, we have to remove the squares, the square root. So we say square both sides. So this will give us, when we square both sides, this will give us 4. That's 2 times 2. 4. Root a times root a will give us a. So that will give us 4ab is equal to 6 times 6, 36. Root 2 times root 2, that is 2. 36 times 2, 72. Divide both sides by 4. You have ab is equal to 18. Now, recall that our a is equal to 19 minus b. So our ab will now come to 19 minus b, which is a, into b is equal to 18. Open the bracket, you have 19b minus b squared is equal to 18. Bring everything on the left hand side to the right hand side. You have b squared minus 19b plus 18 is equal to 0. So this has formed a quadratic equation. So we have to solve this by factorization. We look for the factors of 18b squared. When we add them, we get minus 19b. So we have b squared minus b minus 18b plus 18 is equal to 0. You can see that minus b squared minus b minus 18b is the same thing as a 19b. So we factorize. This will give us b squared minus b minus into 18b minus 18, all will give us 0. This will give us b into b minus 1 minus 18 into b minus 1. This will give us 0. B minus 1 into b minus 18. This will give us 0. So we have b minus 1 is equal to 0, or b minus 18 is equal to 0. Therefore our b is equal to 1 or 18. Recall that our a is equal to 19 minus b. Therefore when b is equal to 1, our a will become 19 minus 1, that is 18. Or when b is equal to 18, our a will become 19 minus 18, that is 1. Whatever the case, the numbers are 1 and 18. So the square root of 19 plus 6 root 2 is 1 plus the square root of 18. Or we can put this, if we further simplify, 1 plus 3 root 2. So we have 1 plus 3 root 2 squared will give us 19 plus 6 root 2. For our b, we are looking for the square root of 24 minus 16 root 2. We will go this way. The square root this time will be root a minus root b, and our a must be greater than our b. So we say root a minus root b squared, which is the same thing as root a minus root b into root a minus root b must give us 24 minus 16 root 2. So this is a times a will give us a minus root ab minus root ab plus b, which is equal to a plus b minus 2 root ab is equal to 24 minus 16 root 2. So our a plus b is equal to 24. Therefore our a is equal to 24 minus b, and our 2 minus 2 root ab is equal to minus 16 root 2. 2 is common on both sides, minus is common also. So we have our root ab is equal to 8 root 2. When we square both sides, we have AB is equal to 128. But recall recall that our A is 24 minus B, so we have 24 minus B into B is equal to 128. Expand, you have 24 B minus B squared is equal to 128. Bring everything to the left hand side. You have B squared minus 24B plus 128 is equal to 0. So we have to factorize now, because this has turned to a quadratic equation. We have B squared minus 16B minus 8B plus 128 is equal to 0. Factorize B squared minus 16B minus into 8B minus 128 will give us 0. So we have B outside, B minus 16 minus 8 outside, B minus 16 will give us 0. So this is B minus 16 into B minus 8 is equal to 0. What this means is that B minus 16 is equal to 0, or B minus 8 is equal to 0. Therefore, B is equal to 16 or 8. So when, recall that A is equal to 24 minus B. So when B is equal to 16, A will become 24 minus 16, which is equal to 8. And when B is equal to 8, A will become 24 minus 8. That will give us 16. But recall that our A must be greater than our B. So our A, we take A that is greater. Our A is equal to 16 and our B is equal to 8. So the square root of 24 minus 16 root 2 must be root 16 minus root 8, which is the same thing as 4, which is the same thing as 4 minus 2 root 2. So when we square this, we get 24 minus 6 root 2. So this is our answer.